Ladies and gentlemen, welcome to the YouTube channel. My name is Mr. Jackson, and before we get into solving two-step equations, I told you when we hit 100 subscribers, we are giving away 5 blue TI-30X IIS calculators. Now again, I know it's nothing crazy, but just because it's a math channel, I thought it would make sense for the first 100, we should give away something, well, math related. So I do have 5 of these that we are going to give out. Again, blue TI-30X IIS calculators. And I'm going to give you guys until December 5th to comment on this video specifically. And I want you to type in the comments, I want a blue TI-30X IIS calculator now. I want you to be aggressive about it, because if you truly want it, you better comment down below. Now also, I want to give you extra time as well, just because the holidays are coming up. So when people start asking you, well, what are you thankful for? You need to say to them, mathematics, because it's the greatest subject in the world. There's nothing to be more thankful for than having mathematics. Now, if they start, spewing nonsense like English and social studies, just stop them there. Just go, quit yapping, bud. Right? It's math all the way. And again, I'll let this run till December 5th. You have to comment that you want a blue TI-30X IIS calculator now in the comments for this video. I'll mention it in future videos as well. And then also comment down below in the same comment, I guess, if you want it signed, whether it's a calculator box, or maybe you don't want it signed at all and you're like, I don't want that guy's signature, he's a loser, which understandable, okay? But I know there's a bunch of you that aren't my students that are subscribed on here, so just so you know, you have a chance just like my students do as well. I probably only have like 6, 7 students that are subscribed to me right now, and the rest are just people that have, seen my videos and the suggested videos, or somewhere on YouTube, however I'm getting pushed out to you content-wise. And without further ado, good luck in the giveaway on December 5th, and let's get into two-step equations. Now, if you haven't seen my one-step equations video, I recommend you go watch that first, and I'll leave the link to that in the description down below. But now we're talking about two-step equations. So first watch the one-step, understand that topic, and then come watch this two-step equation video. So for number 1, I always tell my students to build a wall or separate the left and the right side of the equation by drawing a line right down the middle of the equal sign. And once they do that, now their goal is to isolate the variable, in this case x, and get it by itself with no other numbers around it on the left side of the line. And what's stopping us right now is the -5 that's directly next to the variable and that +3. So to get rid of those, we always want to get rid of the constant first, which is essentially just a number all by itself. In this case, that's the +3. Well, how do I get rid of adding by 3 and make it go to 0? You want to use the inverse operation of addition, or the opposite of addition, which is subtracting by 3. So let's go ahead and subtract by 3 directly below that +3. And I draw this line just because students need to know, well, if you subtract 3 from one side of the line, you have to make sure you mirror it and do the same thing on the other side as well. You can't just subtract 3 because you feel like it without something else happening. So let's go ahead and subtract 3 on the other side of the line as well. Well, 3 minus 3 is 0. These cancel out, which is exactly what we want. And then we bring down what's left. We have a -5x is equal to -17 minus 3 is -20. And x still isn't isolated. It has a -5 directly next to it. Well, -5 is being multiplied to x. Well, the only way to get rid of multiplying, again, is to do the inverse, and let's divide both sides by -5. So divide by -5, divide by -5. -5 divided by -5 is not 0, but it is +1. And well, what is 1 times anything? It's just the same exact thing. So that's why we're left with x all by itself. I'm just going to write that over here. So x equals -20 divided by -5 is going to give us a final answer of x equals 4. We isolated x all by itself and got the final answer as +4. So let's go ahead and do the same thing now for number 2. So let's draw our line separating the left and the right side. And once again, let's get rid of our constant first. In this case, it's +4. So let's use the inverse and subtract by 4 on both sides. So 4 minus 4 is 0. We bring down the -2x, not just 2x. A lot of students forget the sign that they need to bring that down in this equation, or else they're going to get the whole thing wrong just by a sign issue. And then we have -2x equals 6. And once again, well, how do I get rid of -2 being multiplied to x? Let's go ahead and do the inverse and divide both sides by -2. Well, -2 divided by -2 is once again 1, which is just x. And then we have 6 divided by -2, which is -3. So our final answer for number 2, x equals -3. And now for the third one. Draw our lines separating the left and the right side. And once again, let's go ahead and get rid of our constant first. But it looks like this time around, we are going to be adding 11 to both sides because the opposite of subtracting by 11, well, is adding by 11. So let's go ahead and add 11 to the other side as well. 11s cancel. We're left with -19 plus 11, which is -8, equals 4/5 times x. Now, this is the part here that students trip up and make a mistake almost every single time until they start to get the hang of it and understand it. Now, 4/5 is currently being multiplied to x. And you should have learned already, well, the inverse of multiplying is dividing, but if we try to divide both sides by 4/5, for example, this, so we have 4/5 here. I know it's off the webcam, just ignore it for now, you'll be fine. Okay, dividing by 4/5, well, you end up dividing by fractions. And if you learned about dividing by fractions, you actually need to do something special with that, which is known as keep, change, flip. You're actually going to keep 4/5, the original one, the exact way it is. So we're just going to back up a little bit here. So we're going to keep 4/5 the exact way it is. We're going to change doing the division that we were just about to do, and we're going to change it to multiplying. So I'm actually going to end up multiplying both sides by the reciprocal. So it's keep the first one the same, which was 4/5. We're going to change that division that we were about to do to multiplying, and then we're going to flip what we were going to do. Instead of dividing by 4/5, we're going to multiply by 5/4. And I want you to know why this works. So we're going to multiply both sides by 5/4 instead of trying to divide both sides by 4/5. Now look at 4/5 times 5/4. I want you to look at the numbers that are diagonal from it. Well, 4 and 4 are both divisible by 4. Well, what's 4 divided by 4? Well, you end up getting 1. So we can cancel that and make it a 1. And 4 divided by 4 is also 1. And then when you look at the 5s, well, 5 is both divisible by 5. So 5 divided by 5 is 1. 5 divided by 5 is 1. And doesn't that work? Well, what's 1 times anything? It's going to stay the exact same. And we're left with just our variable isolated all by itself on the right side, which is x. Now, could you do 4/5 divided by 4/5 on your calculator and it gives you the answer? Yes, but technically the proper way to do it is to multiply by the reciprocal. The calculator is obviously going to do that work for you, but if you don't get a calculator, you need to make sure that you know how to do this appropriately. So that all cancels. And then, well, how do I do 5/4 times -8? Because -8 is not even a fraction, but I can make it into a fraction by putting it over 1. And then let's check to see, well, can we simplify doing the same thing that we just did on the right side of the line? Well, 4 and 8 are both divisible by 4. So 4 divided by 4 is 1. -8 divided by 4 is -2. And then we can go ahead and multiply our numerators and our denominators. So 5 times -2 is -10. And then, well, 1 times 1 is just 1. So our final answer is going to be -10 is equal to our variable x, all isolated. Now, if it bothers you that the variable is on the right side, feel free to just flip it and make it x equals -10. That's not going to change the value of it at all. Now, if it was inequalities, that's a whole different story, but this is equation. So our final answer is -10. So let's go ahead and take a look at number 4. Drawing our lines separating the left and the right side, let's get rid of our constant first by subtracting 13 on both sides. So -13, -13. This is going to go to 0. We're left with x divided by 7 is equal to 22. Now, notice how this one is a little bit different. We don't have a fraction in front of the variable like we did for number 3. Our x is actually a part of the fraction, but I want you to realize that these are the exact same thing. X over 7 is really just the same thing as 1/7 times x. So us putting it dividing by 7 or 1/7 x, we're going to actually end up doing the same exact thing no matter which route we end up taking. So if we do x divided by 7, well, what's the opposite of dividing by 7? We're just going to multiply both sides by 7. Now, if you would have had it as 1/7 x, well, that's one of those reciprocal ones where we would multiply both sides by 7/1, which is the same exact thing. So regardless of the way they write this, we actually end up doing the same exact thing. So now let's go ahead and multiply the other side by 7 as well. So 7's cancel because those are inverses. We're left with x isolated all by itself on the left side just like we want. And then finally, well, what's 22 times 7? And again, if you don't have a calculator, just take the time to do it on the side. 22 times 7, well, 7 times 2 is 14, carry the 1. 7 times 2 is 14, plus 1 is 15. And we end up getting x is equal to 154 for number 4. And then finally, the very last one before I have 5 questions that I want you to try out on your own in the practice session. So let's go ahead and draw our line, separating once again the left and the right side. Let's get rid of our constant, which is -9. So let's add 9 to both sides. These cancel. We're left with -11x is equal to 99. And then let's go ahead and divide both sides by -11. These cancel. You get x isolated by itself. 99 divided by -11 is -9 for our final solution for number 5. So let's go ahead and dive into the practice session and see if you can go 5 for 5 in two-step equations. Let's get into it. All right, now it's time for the practice session. Do you actually know how to do two-step equations? So I encourage you to pause the video, try out all 5 of these questions, and when you think you have all the correct answers, come back and play the video and see how you did. So I'm assuming at this point you've tried out all 5 and you're ready to go over to see if you went 5 for 5 in the practice session. And if you did, maybe that'll up your odds of winning the giveaway. No, it won't, because I'm not going to skew that at all. Nice try though. But let's go ahead and get into number 1. Let's go ahead and build that wall and separate the left and the right side of our equation. That way we can go ahead and isolate x on the left side. So the very first thing that you should have done is add 9 to both sides of the equation, getting rid of your constant first, and then canceling out those because they're inverse operations. Then you're left with -2x is equal to 32, and then divide both sides by -2 because -2 is currently being multiplied to it. These cancel out, and you end up getting x is equal to -16 for number 1. So hopefully you are 1 for 1 right now, and let's go ahead and jump over to number 2. Once again, let's draw our lines separating the left and the right side. We'll subtract 10 because that's getting rid of our constant. So 10 minus 10 is 0. We show that cancellation. And then make sure that you're bringing down -5x, not just 5x. Then -45 minus 10 is -55. And then, well, how do you get rid of the -5? It's currently being multiplied to x, so let's go ahead and divide both sides by -5. Well, -5 divided by -5 is 1. Well, 1 times anything, it's going to stay the same, which is just x, all isolated. And -55 divided by -5 is +11 for number 2. And then for number 3, I noticed right away, this is going to be one of those keep, change, flip ones because I see a fraction in front of the variable. But let's go ahead and get rid of our constant first. So again, separating the left and the right side. Well, get rid of the -11 by adding 11 to both sides. So +11 plus 11, show that cancellation. -33 plus 11, well, that's -22 equals 2/11 x. Well, how do I get rid of 2/11 being multiplied to x? We're not going to divide by 2/11, but we are going to use keep, change, flip and multiply by the reciprocal, which is 11 over 2 on both sides. So multiplying by 11 over 2. And again, the reason that this works, well, look at the 2's that are diagonal from each other. They're both divisible by 2. Well, 2 divided by 2 is 1. 2 divided by 2 is 1, and the 11's are both divisible by 11. So those also turn to 1, and then 1 times anything, well, you're just left with x, all isolated on the right side. And then for 11/2 times -22, let's make this into a fraction as well. 2 and 22 are both divisible by 2, so 2 divided by 2 is 1, 22 divided by 2 is -11, and then we can go ahead and multiply our numerators and denominators together. So the left side is going to equal -121, make sure it doesn't run in my webcam here, equals x for our final answer for number 3. If you got number 3, you should easily finish the last 2 here with no issues. So let's go ahead and draw our line for number 4, our second to last question for the video, and subtract 18 on both sides to get rid of our constant. 18's cancel out. You're left with x divided by 9 is equal to 36. And then, well, how do I get rid of dividing by 9? Let's go ahead and multiply both sides by 9. Our 9's cancel because they're inverses, and you're left with x isolated just like we want. And then once again, if you can't do 36 times 9, take the time to do it on the side over here. 9 times 6 is 54, carry the 5. 9 times 3 is 27, plus 5 is 32. and you end up getting x is equal to 324 for number 4. And then finally, going into the very last one, let's get rid of that work there and draw our lines separating the left and the right side. We add 18 to both sides. So plus 18, show the cancellation. We have negative 12x that's left equals 108. Divide both sides by negative 12. Our negative 12s cancel because they're inverses, and we're left with x equals negative 9 for our final answer for number 5. Hopefully you went 5 for 5 in the practice session. If you did, very, very nice job on two-step equations. And again, I hope you win on December 5th when we do the giveaway. I'll mention it again in the next couple videos as well. You have to comment on this video stating that you want the blue TI-30X IIS blue calculator. And again, I hope you win. Even if you are across the country, I'm not against shipping it to you. You know, I'm more than willing to do that for you. Just comment that, and then we'll reach out, you know, with details and stuff if you end up winning via email or something like that. Thank you guys for taking the time to watch, and we'll see you in the next video with some more mathematics. And I believe we're on to multi-step equations. Again, I told you if you saw the previous video, you know, it starts off easy and just building blocks, step by step by step. Eventually, we have variables on both sides. So until then, we'll see you next time.